Now before I start this question, what I've done is define my random variable x. Let x be the random variable number of visits per minute on a weekday to this particular server. Now what kind of distribution would x follow? Well, because visits occur at a mean rate, okay, then this is going to be a Poisson distribution. So I'm going to say here that where x is distributed as a Poisson distribution and it only has one parameter, the parameter is the mean, lambda. Now we're going to be testing what lambda is. They say that the mean rate is 7 per minute. So my null hypothesis is going to be that lambda equals 7. Now we've observed on a particular Saturday, let's just call that x for the observed value, that there are 10 visits. So what does this seem to suggest? Well, it seems to suggest that lambda is greater than 7. So that's our alternative hypothesis, H1, that is lambda is greater than 7. If I was to illustrate this with, say, a number line, what we've got is no visits here to the server, but generally we expect about 7 visits to the server. But that can vary, obviously, because things occur at random. So we can expect just round about 7. But the question is, where does 10 feature in this? Is 10 an extreme value, or is it just generally acceptable? If it's an extreme value, it will be outside this, what is called critical region. This critical value, I should say, and it will be in this critical region up here. This critical value I'm going to call R. And there's two ways that we can work out whether lambda has increased if we carry out a 10% significance level test. We'll write down that level is 10%. Alpha equals 10%. There's several ways that we can work out whether lambda is greater than 7. We can do a critical value test. We could find out what this critical value is and compare where 10 is relative to it, if it's in this acceptable region or if it's in the unacceptable region out here. And we do that by considering this, that we would reject HO then if the probability that x is greater than or equal to this critical value here, R, given that the mean lambda equals 7, accepting HO, okay, turns out to be less than or equal to the significance level here, 10%. Less than or equal to, well, I'm going to turn that to a decimal, so that'd be 0.1. That's one way of doing it. Or an alternative way of doing it is that we could reject HO, okay, if the probability that x is greater than or equal to 10, given that lambda equals 7, turns out to be less than 0.1 or less than or equal to 0.1. Okay, the 10%. Now it's up to you which one of these two methods you choose. Now as it turns out, for this question, in the second part we've got to state the minimum number of visits required to obtain a significant result. That in fact is that value R. But I'll do that in the second part, so you can then get an idea of how we could tackle this problem, either by this method or by this method. I'm going to go for this method for this part of the question though. So if we do that, let's just come down here. We'll look at the probability that x is greater than or equal to 10 then, given that lambda equals 7, that the mean is 7. We've got to work it out. Well, being a Poisson distribution, it cannot do 10 plus 11 plus 12 and so on, because there'll be an infinite number of probabilities. So we have to do this as 1 minus the probability that x is less than or equal to the value below this, which would be 9. And that's given that the mean is still 7, okay, that HO is true. And to work this out, well, I certainly don't want to work out 0 plus 1 plus 2 via the formula. I want to use tables. And if we were to use cumulative Poisson probability distribution tables, something like this, we could look up then the probability that x is less than or equal to 9. Just look up lambda equals 7 for the mean, come down here where x is 9, and you'll see you get 0.8305. So what we've got here then is that 1 minus 0.8305. And if you work that out, you end up with 0.1695. Almost 17%. And we said that we would want to reject HO if the probability of x being greater than or equal to 10 turned out to be less than or equal to 0.1 or 10%. And you can see that that isn't the case then. So we've got no evidence to reject HO. So I'm just going to put here no evidence to reject HO. And that's because since that probability, the probability that x was greater than or equal to 10, given that lambda equals 7, turned out to be greater than 10%, or greater than 0.1. As long as you write something along those kind of lines, or say that this value, for instance, is greater than 0.1, then there's no evidence to reject HO. So we can see that lambda still stays as 7. So I hope that's given you some idea then how to go about this part of the question. Now the next part though, I'm going to show you how we could do this part of the question just by using this idea up here of rejecting HO by finding that critical value R. Because we need to find it, we've got to state the minimum number of visits required to obtain a significant result. And if we find that value, we could have compared it to R10. Okay, so I'll run through that then in the next video.